Okay, it's time to start a new section, unit, chapter, I suppose. We're going to talk about graphs a lot in this chapter. So we're going to start by going through all sorts of different types of graphs, 4 or 5 different types. Today we'll talk about broken line graphs. Really important type of graph. I know you're familiar with them, stuff that looks like this, right? You've seen stuff like that before. So all these graphs kind of fall into the category of statistics. So what statistics is, it's the collection, presentation, and analysis of numerical data, right? Basically, you go out and you get numbers. Data is numbers. So you go out and you ask people questions or you study stuff and you get a whole bunch of numerical data, a whole bunch of numbers. And then that's the collection part, right? Going out and getting it. Maybe you're asking questions, maybe observing things, maybe doing experiments. That's the collection. We're not going to do too much of that, although we'll probably do a project or something with that. The presentation, that's how you're going to show people what data you found. That's where the graphs come into play, right? So graphs, tables, not so often, but also just writing stuff out. But it's definitely a lot easier to present data and to understand data if you have it in graphs. And then analysis is when you take a look at the data and you may look for trends, you look for patterns, you look for, to make predictions based on what you see. All right, so starting with broken line graphs. A broken line graph is a graph that uses points joined by line segments. You know what a line segment is? A line segment is a line that doesn't go on forever. So we put points, we join them with line segments, and that helps us to display the data. That's exactly what we have here, right? Point, 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 and they're all joined by line segments. It usually shows some kind of change or trend over time. If you have time involved in your data, then using a broken line graph is often the best thing to do. By the way, time is always going to be your independent variable. So for that reason, time will be down on the x-axis. Maybe I'm even going to write it here. Time independent variable, which we've talked about before. And so it goes on the x-axis. Okay. You can also use broken line graphs to compare sets of data, and to do that use a multiple broken line graph. So 2 broken lines or 3 broken lines. Usually you don't see many more than that, but you could. So this is an example of that, right? There's two lines here. There's 2 broken line graphs, and then we can make good comparisons based on this. Now, if you're going to do that, if you're going to put more than 1 broken line, you got to make sure you're clear what each line represents. And the way you usually do that is you make a legend or a key. And they've definitely done that right down here. They've told you that the blue broken line refers to a website called Music Choice, and the red broken line graph refers to a website called Pop Parade. Now, I better get rid of those green things, otherwise you won't be able to see the colors, the blue and the green, the blue and the red anymore. All right, so let's take a look at this. What's happening is 2 music websites have started, and we're just recording, or we're not, someone has recorded how many people viewed these websites over a specific number of dates. Let's say, I don't know, it's kind of weird just to have the dates 1, 2, 3, 4. Let's say that they started in February. They started in February of 2020. I'm just making that part of it up. But let's just imagine. So then that would mean that this date right here is February 1st, February 2nd, February 3rd, February 4th. Okay, if that helps you understand what the numbers in the bottom mean. But it's definitely a time. Whether you think of it as a date, February 1st, February 2nd, February 3rd, or if you're thinking of it as a time passing, 1 day, 2 days, 3 days, same sort of thing, isn't it? All right, first question, which website is more popular? So, I mean, you do not have to look at a whole bunch of numbers. You don't have to read a bunch of paragraphs. You should be able to just look at this graph and you know which one's more popular. I mean, almost every single month, the red one has more visits. Not every month, but most of them. The red one's got to be more popular, and that is Pop Parade. So, Pop Parade is more popular overall. Okay, what days did more people visit the Music Choice website? There were a few days where more people actually looked at the Music Choice website. Where were they? When was blue above red? No, 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 close. Almost caught him there. Almost caught him there. Whoa, what happened? Red one was on fire there. And right here, you've got blue a little bit higher here, and blue's a little bit higher here, and then that's it. It falls below again. So it's just those 2 days. What days are those? 12 and 13. So if you want, you could just put 12th and 13th days, or if you want to go with my February thing, you could call it February 12th and February 13th. Next, how many people visited the Pop Parade website during the 11th week? Okay, 11th week is right here. And we're interested in Pop Parade, which is the red one. So if we go up from the 11th week, this is the one we're interested in right there. So where's that at? Well, let's see, it's between those two lines, and the two lines are 140 and 160. So I would say it's right in the middle, which is about 150. So there's our answer, right? Right? Our answer is 150? Wrong. Why is that wrong? Because if you look over here, it says what these numbers represent is number of people per thousand. Like, that's the number of thousands of people. So in fact, it wasn't 150 people who looked, which isn't great. That's about how many people look at my website every day. Not great. This is 150,000. I can only dream of having such numbers. Why don't people want to look at my website? All right, how many more people visited Pop Parade than Music Choice in the 4th week? Oh, we got to know how many more. So this is going to be a kind of a 3-step question. We got to figure out how many people visited Pop Parade on that day, how many people visited Music Choice on that day, and then get the difference. So 4th week is right here. So if we look up from there, the two we're interested in are this one and this one. So let's do Pop Parade first, which is the red one. So if we go up to the red one, it looks like it's right on the line, which means it is 100,000, right? 100,000. That's a lot of people. 100,000. Or of course you could write it like 100,000 because that's what that means. Okay, for the Music Choice, that's this one. Also looks like it's right on the line. Looks like it is 20,000. Or if you want, 20,000. Now we want to know how many more people visited Pop Parade. So if we want to know how much more 100,000 is than 20,000, we just need to subtract. So when we subtract, we'll get 80,000. Or of course you could have done it here. 100 minus 20 is 80, and you still have the 1,000. So the answer is 80,000. I'll just do it like that. 80,000. Okay? There you go. Now let's make one. So we're going to make a broken line graph. It refers to net immigration. And net immigration is the difference between the number of people leaving a country for permanent residence in another country and the number of immigrants. So for example, in this case we're looking at Canada, net immigration to Canada. Some people every year, there's a group of people that leave our country, Canada, and they go and live in other countries. Maybe they go live in the United States. They go move to France. I have a friend who's just moving to France this week. Right? People move all over the world. Then we have other people who move to Canada. They come in from, maybe they're refugees, maybe they have family here and they've always wanted to move here, maybe they're coming here for work or whatever. So what we have here is the net number of immigrants. So in other words, there's more people coming into Canada every year than moving out. There's more immigrants than emigrants. So we're going to record this data. We have year. Here's the different years, and that's a time, isn't it? So guess where that's going? On the x-axis. Well, let's start with that. Year. So I'm going to put year down here. Now, we're not exactly starting at year 0 or anything. I don't even know what that would mean, starting at the beginning of time. So you probably don't have to do this if you have actual years, but I'm going to put that broken line to show that, we're starting kind of in the middle of something. We're not starting back at the beginning of time. So actually what we are starting at is the start of Confederacy, I believe. Isn't that when Canada started? So 1867, and then it goes up by 20 years every time. 67, 87, 07, 27, 40. Yeah, it's going up by 20 years every time. So let's be smart about this, and let's start with 1867 and go up by 20 every time. So 1867, 1887, 2007, what the heck, we'll do one more, 2027, and we're good. Okay, the other information we have here is the net number of immigrants. Oh, look it's per thousand again. So I'm going to call this net number of immigrants, and I'll put in brackets that this is thousands. The number we put down refers to thousands. So it looks like we start pretty low, so I would say we start down at 0, and we have to get up to at least 260, probably a little higher in case we want to look for trends and stuff. I know I can put 0 here. I don't need to break it. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines to work with, and I want to get to at least 260. Maybe I even want to get as high as 300. Let's just see. If I wanted to get as high as 300 and I have 12 lines to work with, if I do 300 divided by 12, that gives me 25. That's a nice amount to go up by. I think I'm going to do that. So it goes 0, 25, 50, 275, and 300. Okay, it's time to graph our points. So in 1867, there were 15,000 immigrants. So the first point, I know it's hard to read 1867, terrible writing. 15,000, well, halfway would be 12 and a half, so it'd be a little bit higher. So about there. Doesn't have to be perfect, but do the best you can. 1887, 90. So 1887, and we're going up to 90. So it's going to be close to 100, but, a little ways off. 1907 is 150. Yes, that's exactly on a line. You got to love it when you get exactly on a line. 1927 is 100. Oh, it came back down. 1927 is 100. It's another perfect, pretty point. 1947 is still at 100. Oh, I love all these pretty points we're getting. We're so lucky. 1967, 200. Whoa, we're going way up. Isn't that the summer of love? I believe 1967 was the summer of love. Hippies everywhere. 1987, 130. So we're going back down to 130. So that'd be a little bit above 120. 87, I was in grade 9 or something. 2007, 260. So that's way up. Whoa, I have to go up even higher than that. 250 here. 260 would be right around there. Okay, now, sometimes you want to do a line of best fit, like I showed you in the last video. But this is definitely one, since we're looking at year to year to year to year, you want to join them all with broken lines. This is why it's a broken line graph. So let's do that. So there we go, there's our first one. Then it continues up to here. You see I'm doing a brand new line for each one. So there, where'd I go to? Oh, I have to go up here next. Then down to here. And then up to here. Interesting. It's kind of got these one peak down, another peak down, another peak. Kind of makes you wonder if it's going to go down here. Anyway, we'll talk about that when we get to our questions. Oh, you know what I never did? Never put a title. Okay, there you go. I didn't want to waste time you watching me write stuff. So there's our table, our graph. So our broken line graph. Looks pretty good. Let's answer some questions. Estimate the net number of immigrants in 1917. Is this interpolation or extrapolation? So 1917, where would that be? Well, here's 1907, and here's 1927. So that's 20 years difference. So right in the middle would be 10 years more. Oh, that'd be 1917. It'd be right there. So how are we going to estimate that? Well, we're going to draw a line straight up from there until we hit our graph. Oh, it's actually right on the line. That's nice. And then over from there, and we more or less get 125. Remember, we're talking about thousands, so 125,000 immigrants. Is this an example of interpolation or extrapolation? Well, that date, 1917, was within the dates we know. We have data from 1867 up to 2027. 1917 is definitely within that range. So this is an example of interpolation. Okay. The last question is, estimate the net number of immigrants in mistake. That should say 2017, not 1917. I guess I cut and pasted and forgot to change the date. I'm sorry. So 2017, where would that be? Well, here's 2007, 2027. So that's 20 years difference. If we go halfway, we've gone up 10 years. 10 more than 2007 is 2017. So we're going to go up from there until we hit the line. Uh-oh, we'll never hit the line because it doesn't keep going there. So what do we have to do? We have to extend the line. Now, this is the thing. How do we extend it? Like if you look, it often goes up, down, up, down, up, down. So one way you might estimate this is it goes down kind of like this, right? All our peaks seem kind of symmetric when they go up and go down. I think that'd be a pretty valid estimate. Or maybe you think, well, I can see what's happening now. It's going up, 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 up. I just think it's going to keep going up. Maybe you think it's going to keep going up like this. I mean, we're going to get vastly different answers depending on what we predict here. By the way, is this interpolation or extrapolation we're doing? Remember, we only had data up to 2007. So if we're now doing 2017, that is definitely extrapolation. And we talked about this before. Extrapolation is more risky because you have to make an assumption about what's going to happen with the data. And in this case, I think there's two good valid assumptions. You could either think it's going to come back down like this, or you could think it's going to go up like that. Why don't we do both? And then, you know what we'll do? We'll look it up and see what the right answer is. So if you thought it was going to come back down, you would go up from this point to here. Oh, another right on the line one. I love it. And then you would go over and you would get 225,000. So we'll put that down as one of our estimates. Wrong color. Oh well, it's okay. Why did I put thousands there? That's weird. Now, if you did not think that was it, if you thought it was actually that the immigration kept going up, net immigration, what would be our estimate there? Well, we would think the line would keep going up, up, up. I'm just going to extend it here, and we would think it goes up to about here. So it's actually a little more than 300. I don't know, probably about halfway to the next one up. So somewhere around 310,000. I mean, that's a huge difference. Whether it's 225,000 or 310,000, that is a massive difference. This is the problem with extrapolation. Now, should we see what the actual answer is? Okay, give me a second here. Here you go. I hope you can see this okay. Right here is Canada, and the migration or net migration for 2017 is right around 88,000. So how's that compare to what we said? We had one prediction of 225 and one for 310. Wow, we were quite a ways off, weren't we? Thus, the dangers of extrapolation. But wait a minute, I just want to make one point here. Remember when we did the 1917? Do you realize that that's actually pretty risky too when we made that prediction? Any ideas what was going on in the world in 1917? Oh, just this little thing called World War I. So I would imagine that would have a strong impact on immigration. We joined these 2 points with a line, but we don't know for sure that it went like that. Maybe over that time, when the war was on, maybe it went way down during the war and then came back after the war like that. Or I don't know, maybe people were trying to escape the war in different countries and immigration to Canada went way up and then came back down like that. So even with interpolation, we don't actually know for sure that this was what actually happened, but it's a safer bet than with extrapolation. Okay, everyone. Looking forward to discussing more graphs with you.